Okay, I'm going to solve several equations with rational exponents. And so here we go. Oh, I'm sorry. I can't read my own handwriting. It's supposed to be 512. So x to the 3/2 equals 512, or 512. So what I need to do is I need to get rid of the exponent. So to do that, if I raise it to the reciprocal power, so 3/2 is raised to the 2/3 power, these multiply together and give me x to the 1. But if I do it on the left side, I also need to do it on the right side. And so using my calculator, I enter into the calculator 512. And then if I'm using one of the newer calculators, when I use the exponents, it's going to put it in the little box up there. And so I don't have to do anything special. But if I have an older calculator, I'm going to have to put the exponent in parentheses so that it knows to take the whole thing to the 3/2 power. And that comes out to be, I have my own calculator here, 1, 2 to the 2/3, 64. The next one, x cubed plus 3 equals 67. So I start by subtracting the 3. So I get x cubed equals 64. If I take the cube root of both sides, that will cancel the cube, and I get x equals the cube root of 64. Some of the calculators have the cube root button. If you don't have it or you don't know where it's at, you can use the little caret, and just remember that a root is 1/3, or remember the rule that if you have the nth root, that is the 1/n power. So you can put that into your calculator, 64 to the 1/3 power. And we get 4. So that is our answer to the second equation. The next one, x minus 1, x minus 1 to the 5th equals 32. So the first thing I do is I can either take the 5th root or raise it to the 1/5 power. The result is the same. So 5 times 1/5 is 1, so that cancels, and I get x minus 1 equals 32 to the 1/5. Putting that into my calculator, I get 2. And now to solve for x, I add 1 to both sides, and I get x equals 3. The next example, x to the 4/5 minus 6 equals 10. So I start by adding 6 to both sides. I get x to the 4/5 equals 16. So I'm going to take this and raise it to the 5/4 power on both sides. And so I multiply here, and 4/5 times 5/4 is 1. So I get x to the 1 equals 16 to the 5/4. So if I have an older calculator, I would enter it like that into my calculator. And it comes out to be 32. X plus 2 to the 2/3 power equals 27. So I need to get rid of the rational exponent. So to do that, I raise both sides to the 3/2 power, and that crosses off. So I get x plus 2 equals 27 to the 3/2 power. So 27 to the 3/2. And it doesn't come out to be like an integer. So what I'm going to do, I can rewrite this. The 1/2 is a square root, so I can rewrite it like this. And then 27 cubed is 19,683. And I can subtract 2 from both sides to get x equals -2 plus the square root of 19,683. And then you could simplify this exponent, or this square root, some more. In the last example, 2x minus 5, or 3 times 2x minus 5 to the 5/3 plus 1 equals 9,376. So I start by subtracting 1 from both sides. (9,375) divide both sides by 3. So I need to get the term that's raised to the exponent all by itself. So I get 2x minus 5 raised to the 5/3 power, and then 9375 divided by 3 is 3125. And so now to cancel the rational exponent, I raise it to the reciprocal power, and I do it on both sides. So I have 2x minus 5 equals 3125 raised to the 3/5 power. And remember to put it in exponents. So that's 125. I add 5 to both sides, and I get 130. 2x equals 130. Divide both sides by 2. Equals 65. So x equals 65. And that is the answer. So that's it for this these set of examples.